Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Hello and welcome back to GOTO Unscripted. I'm your host today, James Lewis. Thank you for joining us. Good morning, good evening, good afternoon, wherever you are in the world and whatever time zone you're in. Today I'm at GOTO Aarhus and I'm joined by none other than the great Sam Aaron, creator of Sonic Pi and, well, originally Overtone. And we're going to be talking a bit about music, a bit about his love of teaching, that sort of thing. So, Sam, maybe you could, the great Sam Aaron, maybe you could introduce yourself.
I wouldn't say that at all in the slightest. I'm Sam. Yeah, hi. I'm a programmer, now turned to a musician. I love programming, I love music, and I love finding ways to explore the creativity of code and using code as a form of expression, really. And I use that obviously personally because I really enjoy just using code to express myself, and particularly through music, but also predominantly to use code as a way to, to use the expressivity of code as a way to teach computer science in schools and to try and get that next generation of programmers, not just to be able to program, but hopefully try and change a sort of social perspective of programming, that it's not just a tool for business, but it's really a powerful, expressive tool for humanity.
It's like a socio-economic, socio-technical kind of construct, programming for the greater good, if you like.
Absolutely, and I think the problem is that most people in society don't really know what programming is at all. When you see it on the TV films and movies, it's just like The Matrix. It's totally not. Well, that's a typewriter, right? But it's like totally not what the reality. And so I don't think people know what it is. And so I usually explain this issue through analogy of writing, where I invite people to imagine a world where writing is only ever used for business/legal usages. And would that be a world you'd like to live in?
I can honestly say that no, I wouldn't like to live in that world.
So I think that's the problem is programming is that world right now. And so, because it's so young and so nascent, and we're still banging sticks together. And it looks all sort of futuristic and science fiction-y, but it really is very, very young compared to many other disciplines that humans have created and explored and researched and worked on. So I still think there's a huge amount of exciting things to happen through programming. And I'm hoping that we're going to see more exploration of things that are not necessarily related to business and business needs.
It's super interesting. I mean, so there's 50 things to unpack just in that opening statement, which is brilliant. So, I mean, because you talk about the programming being a very nascent sort of thing, computer science is new. But you also, as you said, you're interested in music and things. So, which is amongst the oldest of things that humanity does, right? Banging rocks on other rocks, I guess, is music, right?
Yeah, no, I think I remember watching a video of some person talking about cave person instruments, which were literally different rocks that were tuned. They found the rocks that had different melodic constructs, and we banging them to make melodies. And I also read somewhere, whether it's true or not, we don't really know, obviously, that there's a possibility that music came before speech.
Oh, right.
So even that level of ancience, music is deeply ingrained in our humanity.
And so what brought you, what made you bring the two things together? What was because you described yourself as a computer scientist and then a musician later on. Were you a musician before? I mean, did you play instruments? And
I'll answer that in a sort of sarky way, and then I'll answer it in a more appropriate way. And the sort of sarky way is that I have this question a lot when I go to conferences and people meet me and say, did you learn music before you did the computer science and music stuff? And it's like, my response always is, well, what domain do you currently program in? And they'll say, banking. Or they'll say, whatever it is. And I'll say, were you a banker before you were a programmer? And they're like, of course not. And they don't see that's the same as asking me the same question. And actually, the beautiful thing about programming is you get to explore the domain you're in through the programming and learn about that domain through the programming. And so Yes, I mean, to answer your question correctly, I did have a background in music. And in school, I played in a jazz band, clarinet and saxophone, and I played in a county wind band.
Yes. Yeah.
They're very much the same kind of thing to me. But also, really early on, my first experience of programming was on a Spectrum 48K. Yeah. And the programs I wrote on that, because it was amazing, these things, you could turn them on, and the little programming environment popped up, nothing to download or install, it was just there. And there was a manual.
Yes.
And you could read the manual, and it would tell you how to use it.
Yeah.
Brilliant.
Yeah.
Like, where's that today? And so one of the first things you could do is you could learn the programs to, they had a very simple basic in the Spectrum, but the basic had some cool functions for drawing and for cool functions for making beeps and sounds.
Yes. Yeah.
So I made it draw a little house and play a little melody.
Yeah.
That was one of the first things I ever did. So even from day one, I was programming music and coding at the same time. So I don't think they were separate at all. Really.
It's interesting because you mentioned that you were in a wind band and jazz band. I mean, interestingly, I was as well, right? I was in the county
What
wind
did you
band.
play?
Well, I was a percussionist, right?
Oh, nice.
So
you got to do the really...
Yes, I did. I got a gong. I played the gong at the Royal Festival Hall. One bong at the end of Bastard Carter and Fugue. Yeah, that's you had to get that right exactly. Yeah. Yes, it was great. Apart from the gong, this was the review. You know, who let that idiot loose on the gong? Sorry.
Was that stressful though to actually get that right?
It was quite stressful. Yeah, I mean, the reason I was sort of bringing that up is, I don't consider myself a musician, but I did learn a lot of the formal I had sort of formal education, if you like, in being able to read treble clef and bass clef and percussion syntax and those sorts of things, right? So, and when I see, coming on to the tool that you've built, Sonic Pi, which you use to teach a lot, and then live DJ and all these really cool things, I can sort of see when you're writing the code, when you're live coding, I can kind of translate that in a sense in my head. Is that something, do you think you would have had to have done that if you didn't know it already? Do you see what I mean?
Well, I don't think I did know it already, to be honest. I do remember right in the early days of Sonic Pi, not knowing what chords were or scales really. I'd done enough to do my grades and just did the things. And that's just basically listening to the teacher and repeating it. But I didn't really understand it. And obviously to code something, you have to really well understand it to be able to code it properly. So I remember having a friend who was doing a master's in music and bringing them over to my house and plying them full of beers and saying, tell me what a scale is. And he would explain it to me in words I didn't understand. And I'd try and understand it and say, no, I'm sorry, can you try again and try again? And then when I started to feel I had some kind of grasp of it, I would code something and then show it to him and he would say, oh, it's almost. And through that process, I had to learn what this was. So I definitely had to do a lot of learning and still do very much. And there's still a whole ton of stuff I'm going to apply to the software I'm working on that I don't fully understand yet. But also, I'd like to try and possibly pick on your statement where you said that you weren't a musician. Because I think I hear this a lot.
Yeah, maybe.
And it's like somebody who's saying they're not a sports person. And if they're saying they're not a professional sports person, I can appreciate that as a statement. If they don't make their money, play for a professional football team or whatever.
Yes.
But they happen to still play on a Saturday league, or they just play with their kids in the park, or just enjoy it a bit. So I think that there's a big stigma around people not being musicians, and because they don't feel that they're professional musicians. And actually, I think we mentioned this earlier, just now. Music is part of humanity, and we're all musicians. And if you can hit a stick on a table, then you're a musician. You might not be a professional musician. I'll agree with that. But you going from saying you're not a musician, but then being able to read music notation, that's already like.
Well, I suppose, maybe back in the day. Yeah.
But even now, so I think it was really important that people understand that everyone is a musician, and it's something that everyone can enjoy, and you don't have to be a professional in anything to enjoy that thing.
And I think that brings us neatly on to the topic of, maybe let's talk a bit about the tool first, so people who haven't come across it will sort of, I guess, understand a bit about what it is, what it does, how you use it, and these kind of things. So it started off with a library for Clojure, I believe, called Overtone many years ago.
Yes, that was one of my first. I was very interested in the idea of using code for music. It was actually one of these conferences, actually the GOTO conference. I was going into the party afterwards and saw a band playing. I was like, this is a programming language conference. Wouldn't it be cool if people could code the music? And of course, then you start to do the research and you realise that people have been coding music ever since computers have been around. In fact, even beforehand. So Ada Lovelace, when she was working with Charles Babbage on the difference engine, she was capable of looking at this very simplistic, as we see it now, but then quite sophisticated mechanical machine that was just designed to do like mathematical, numerical computations and project that this is something that actually could potentially be used to make music from our dreams. So this is like not a new idea. And obviously automation and music have a huge history, just like, in saying like knitting or weaving. So I then found lots of other people doing it and looked at what was interesting. And I was very interested at the time in the programming language Clojure, particularly for its concurrency, semantics, and immutable data structures seemed to be like very interesting to me. And I also
it was a huge splash when it arrived, Clojure, right?
Yeah, I was there with one of Richard's first talks.
I was there as well here.
And it's like, this is super cool. And then I also discovered something called Super Collider, which is an open source synthesizer for audio synthesis, which has a network API. It's super powerful, amazing. And the programming language that the Super Collider used for its execution model was very much related to Ruby, which I'd been playing with before, and I was wanting to move away from. And so I was like, well, why would I spend time learning something which has the semantics that I'm not looking for? And maybe I'll see if I can find a way to get Clojure to talk to Super Collider, because it has this network API. And I was living in Amsterdam at the time, and one of my friends said, I met this guy called Jeff Rose, and he's working on this thing which is combining Clojure and Super Collider. I'm like, okay. So we made instant friends. And so we worked on this project together. And that was really fun. It was basically a really nice DSL, list-based DSL, which allowed you to design synthesizers and interact with them, essentially just programming and controlling Super Collider. And we designed it to be the most powerful programming system we could imagine. So treating yourselves as wizards. And I've got a few thoughts about this, because I think that was a mistake in essence. But what we did is we thought about it in a way that I think people traditionally talk about programming languages, which is language A is much better than language B, whatever it is, because the semantics are superior, or you can test it better, or you can mathematically prove that this isn't possible. Its memory is safe, or whatever it is that or it's a more elegant solution, and so we were trying to do this in that kind of guise. But for us, it was more about liveliness, being able to modify things in real time, and expression in terms of being able to not be limited to imagine new kinds of sounds and synthesis techniques, and then be able to make them into a reality. But what I didn't account for was how much complexity that included, which then became a huge barrier to entry for anybody really trying to do this, because not only did you need to learn Clojure, you also needed to learn sound synthesis. And so I remember going to Clojure conferences and giving talks, and afterwards I went down the corridor, and obviously there were other attendees from the conference there, playing with overtone, making crazy funny sounds, and it's like noises, but nothing really ever came from that. And I think that was because I hadn't really understood that these are social barriers are really important, but it's also the barrier of time as well, how long it takes you
to learn something.
Learn it, and even if you do know it, how long it takes you to build it. So the
affordances that you need sometimes when you're using or trying to do something that is inherently quite complicated, actually, which is live coding of music, is clear. And it can be made as simple as possible, but no simpler, I think, is the old kind of thing, right? And you need some of these affordances to guide people along the path. So Overtone came first, and then Sonic Pi came later. Now, did Sonic Pi... So I know you do a lot of work in schools, like helping kids learn programming, and you're deeply involved in that, deeply passionate about that. Were they? Did those things happen at the same time, or is it? Did you build? What came first, chicken or egg? Like Sonic Pi to help teach, or teaching and then needing a tool that you could use to teach? Do you see what I mean?
Yeah. So I was working at the University of Cambridge, in the computer labs, and my contract was about to expire, and it was the same year that the Raspberry Pi Foundation spun out the labs. And they had this wildly successful, very affordable computer. and a remit to teach computer science to children. But they had a problem that there wasn't really that many capable pieces of software which ran on this very low-powered computer. Most of the software that was being developed was web-based, and this thing didn't really run web browser very effectively. You tried to go to YouTube and kind of didn't do anything. And even things like Scratch at the time, that was implemented in Smalltalk. And that just didn't run effectively at all. I remember they hired external people to try and optimize it, to actually get it to run there at all. So this was like, they got this thing, it was selling, but they didn't have any good software. And so there was a small budget from Broadcom Foundation, they're the people who make the chips for us, for a 3-month project to, as I understood at the time, to help try and think about a piece of software that might help teach kids how to code. And I kind of like waved my arm and said, maybe I can adapt my overtone software and build something similar for the Raspberry Pi. So that's how that happened. And in the first meeting, I was quite shocked really, because that wasn't what they wanted. What they wanted was that and a load more. So in 3 months, they wanted me to develop this piece of software, implement it, find a teacher to collaborate with, go into their school, teach a curriculum, a course of computer science with the software, and evaluate it in 3 months. So it was already very much a constrained kind of project, which was like, well, okay. So I stopped everything and focused on this. And so Sonic Pi was born, and it took 2 weeks to build the first version, because I knew that if I spent any longer than that, then I wouldn't have been able to do all the other stuff. And so I was like, what is the smallest possible thing I could build that would allow me to go and do one lesson in the classroom? And one of the things, and this is at the same time that the UK had the computer science curriculum. So there was an organisation called CAS, Computers at Schools, headed by Simon Peter Jones.
Yes, also in Cambridge at the time.
Yeah, absolutely. And they pushed for this new curriculum, and it was nice, and it has lots of interesting concepts like sequential programming and conditionals and variables and algorithms and data structures. And so I was like, which was the one I think would probably start with? Sequential programming. So that's a sequence of instructions where you start at the top and work down. So I'm going to play a note and wait for some time and play another note, and that'll be lesson 1. So that's what I implemented the first time. So schools definitely came first. That was absolutely the focus of Sonic Pi. And I always saw it in the early days as sort of a toy system that could be interesting in a school context, but I was definitely still interested in overtone as my primary tool for expression, because at the time I was actually already starting to achieve what I wanted to do, which was performing at conferences. I was going around the world, going to conferences, performing with overtone. I even made a band with my brother-in-law. We called ourselves Meta-X, because I'm an Emacs nerd, and and so we did. So that was doing really well. And so the Sonic Pi thing was kind of a way of continuing to work at a university context on musical software, and then also a way of I implemented it so that the synthesizers, the sounds in Sonic Pi were actually the closure and overtone sounds. So I could actually take the work I'd be doing in Sonic Pi and make use of it. In my performances.
And of course, I mean, fast forward a number of years, you've spent a lot of time developing the software. It's pretty amazing. I recommend you going out and having a look at it. It's obviously open source, not obviously open source. It is open source. We'll come to that maybe in a bit. And it's incredible what you can do with it now. It genuinely is. It's got visualizations in it. It looks like a I don't know how to. It's a full featured piece of software in order to be able to live code, basically music. I went round in circles then, but then never mind. So fast forwarding, what would you say? What are the challenges of using this software to teach children in schools? Then, I mean, what are what constraints is placed on the design of the software then, by the fact that you're using it in schools, and that's the primary purpose of it, if you like. Were there a set of design constraints that you had?
Absolutely, and I mean, I could talk for hours about that. And they really both informed the development and design and philosophy of Sonic Pi, but also changed fundamentally the way I approach software.
Right, okay.
So, of course, there's obviously the main constraint that you're working with people who don't really know anything about software, because you teach them how to code. That's the children. And then the teachers primarily don't necessarily have a background in computer science often. So you're dealing with beginners in many cases, and also making things as simple as possible to onboard. Because the amount of time constraints in the classroom that was one of the most surprising elements.
Yeah.
When I got into that classroom, first of all, and saw that half an hour lesson or that 45-minute lesson, most of it's about management of behaviour and getting everyone to listen. And then the teacher has that 2 minutes of their attention. And what are your 2 minutes sentence that you're going to say they're going to get them excited by programming? So already you had to have something which gave immediate response that was interesting. And that turned out to be the most interesting focus. It didn't turn out to be that hard to implement a language which exposed the basics of the computer science curriculum in the UK.
Right.
And in fact, you can just look at history and then just go back and look at Seema Papert and Cynthia Solomon, pick out logo, and you can work with that. Right.
Yeah.
So the hard part, it turned out, and the interesting part to me at least, was how do you actually engage the children? How do you maintain their engagement? How do you capture their interests? How do you maintain their engagement? And that actually was both a challenge because it's hard to do that, but also a challenge because doing that could and did, so I was really trying not to, interfere with the teaching of the core computer science.
Right.
And so making something cool and fun might have been something that got in the way of teaching the variables or the data structures. And if that ever happened, the teacher would never be interested in pursuing this because it was not what they were trying to do. Their learning objectives were set. We had to teach those things, and the shiny stuff, Sam, it looks very nice and pretty, but the kids aren't getting the learning objectives met. So we're wasting our time. So
you mentioned something about that yesterday, and Sam did a brilliant talk yesterday where you talked a bit about concurrency and how that sort of was a bit of a barrier at the start.
Absolutely. I mean, that was a critical one. The kids wanted to play the drums at the same time as the bass.
Right.
And
who'd have thought?
And to do that, you need concurrency. But also a band itself is concurrent in nature.
Yeah.
It's like you have multiple people playing at the same time. And that's actually much more natural and obvious than a single person band. So concurrency is a really natural state of affairs in music. But of course, it's not on the UK computer science curriculum for schools. And so when the children are asking how to play the drum at the same time as the bass, the teacher would say, no, we can't teach that because it's not on the curriculum. So here's a really good example of where we have something which would maintain and keep them, where not only would it maintain their motivation, but they're already motivated enough to ask about this. Like, I want to do this interesting thing that you haven't told me is even possible. That's an amazing, like, to get the child to be in that state where they're going to ask that question. It's an amazing thing. And so it's a precious, it's like the seed is just like popped out and the flower's just about to sprout. And then going to that child and saying, no, you can't do it, it's on my curriculum. It's like stamping on the flower and crushing it. And it was really demoralizing. So I put a lot of effort into sneaking in features that maybe weren't in the remit of the project, and maybe that the funders probably weren't that interested in seeing their money being spent on, but directly help maintain that engagement. And also then that then made this concept really grow out in terms of, hey, actually, if we can make it more musical and more interesting, really what we want to be doing is getting the artists that the kids are looking up to and appreciating to be coders. Because if that's possible, if we get Taylor Swift to make a piece of music with Sonic Pi or a similar piece of software, we'll have 1 million coders tomorrow. And so then I really then focused on making the app not just something that was useful in the school context, but also something that was a powerful tool for expression for musical and artistic people. And in a way that didn't sort of one stop the other. So I was really always careful with any feature to make sure that, hey, this is a really cool musical idea. I can see musicians using this in the DJ platform, but it's not getting in the way of teaching those basic computer science lessons. And that was something that I remember, and still today actually, a lot of people say, well, that's crazy, Sam. You can't build something that's both simple for kids and super sophisticated.
And deep enough for,
And my response to that is like, what is a guitar? And like, oh, okay, like anyone can pick up a guitar and strum the strings, but then you can then practice that and you can do amazing. You can be Jimi Hendrix, you can play beautiful Spanish flamenco guitar. And it's those artists that people admire are the motivation for people picking up a guitar. it's not because it's a technically sophisticated, beautiful instrument. Some people might pick it up for that, but most pick it up because they've seen their favourite artists.
Yes, because it's cool, and they think they'll make friends.
And not because the schools tell you must learn this in the curriculum. It's because they want.
That's why people play the trombone.
They want to have fun. So, like, what is the equivalent for code? What is a guitar for code? And that's Sonic Pi is my attempt to make a guitar or a piano for code.
And obviously, you said that we've got the GOTO Aarhus conference party tonight. I believe you're playing, you're DJing tonight.
So full circle. So from saying wouldn't it be cool if we could code in the party, to me actually coding the party.
In the party tonight. It's fantastic.
It's going to be great.
Super looking forward. I'm really looking forward to it, actually.
Yeah.
But I mean, another thing you mentioned in your talk, which I think you sort of touched on a little bit just now, is this aspirational thing. You know, and you showed a great picture. I can't remember who the artist was or who the DJ was in New York.
Oh yeah,
I think
it's Sarah Davis, DJ Dave.
DJ Dave.
She's based in New York. She's playing huge sets now. Yes,
and that's amazing. Being able to show children that actually this is accessible to them in a way that actually I think is even more important from a social perspective these days than it has ever been or has been for a long time. In the sense that many kids will have access to something that they can use Sonic Pi on, if you like, when they might not have access to an electric guitar or a violin anymore.
Absolutely.
Because, certainly in the UK, there's been a sort of shift in education, hasn't there? And
across Europe in general.
Yeah, you know, there's not so much access to this stuff, whereas this is accessible. I mean, I don't know. I mean, that must be really pleasing for you to be able to provide that. Sort of
I mean, it's depressing that schools are cutting their musical curricula. I mean, I had a teacher in the northwest of England contact me because Sonic Pi wasn't working on their machines, and we figured out a solution and got it working. And because Windows is installed in all sorts of different ways on the school, so trying to circumnavigate, their problem was that they weren't allowed to run batch files. Sonic Pi uses batch files to set up the environment variables.
Right.
So I had to so their security system wasn't allowing this, so I changed it so it didn't use batch files. So it's like, your security system doesn't seem to do much good. But anyway, I contacted this teacher because I was interested in well, how are you using it? What are you using it for? And it turned out she was a music teacher that was still employed by the school, but the music curriculum was being reduced. And so she was taking over the craft and design technology lessons. And so she was then using that as an opportunity to teach some computer science and some music at the same time to build, I think maybe it was ringtones or for an object they were building. So she was sneaking it in, and so it's sad because this is not a simple thing you can apply everywhere. And so it is frustrating to see that. And then also it's frustrating that typically in the music world there are a lot of gatekeepers who decide what music is.
Right.
So if I go to a computer science teacher, they're all over it. They're like, yes, we need anything that can get the kids excited. It sounds great. Whereas I feel that's because, I'm guessing here, but the computer science landscape is constantly shifting. There's new things all the time, and keeping up with that is a tricky job itself. But they're used to change and churn. Whereas in the music world, they're still studying the greats, and they will be in 10 years and in 20 years' time. So it's much more glacial, the movement of the curriculum for music.
You told a funny story about jazz, I think, yesterday.
Yeah, so that was I was in a lift. I was nominated for an award, actually, Music Teachers Award. So I went to this fancy dinner with bow ties, and someone was playing the piano, and someone was taking the Ferrero Rochers around. And I was talking to the top two people from the Royal Associated Board of Music. So these are the people who do the grades for pianos and clarinets and classical instruments in the UK. And telling them what I was doing, they were actually really interested, and it was lovely to hear their response. And they sounded really enthusiastic. So I was like, okay, let's take a punt here. And I said, so when might you consider introducing grades for live coding? And they went, well, Sam, we've just introduced jazz. And they were really pleased about this. And it's like, that's just 100 years old, jazz. So we have to wait.
It might be a little while then.
Glacial speed,
But I mean, as you say, it is absolutely aspirational when you see like a room, a club full of people all jumping about kind of to this stuff. It's pretty amazing. And actually many others have taken it on as well. I've been to other conferences where people are using your software to do the same thing, So super, super exciting.
And it's also important to point out that mine is not the only piece of software that you can do live coding with. There's tons of really cool pieces of software out there. All have their own affordances. In the same way, a violin is slightly different to a piano, slightly different to a trumpet. So it's like Sonic Pi is one of many cool pieces of software to live cooking.
He's very good at doing that, isn't he? It's very, very good of him. You could have doubled down then and say, no, mine is his is the better. I'm not saying.
No, I mean, one of the most exciting other alternatives is a piece of software called tidal cycles.
And so one thing I've been fascinated by with Sonic Pi is that whilst it seems a simple piece of software, it generally, because I've used it myself badly, but it is a simple piece of software to use. It's incredibly well designed. And yet, from the surface, but then when you actually think about some of the problems you must have had to solve to build it, there must be some quite deep comp sci stuff going on under the hood. I mean, I think we were chatting briefly yesterday. You mentioned about, this is human real time.
Yes.
Right? There's difficult problems to solve. I mean, could you just maybe talk about some of those things you had to do?
Time is the crucial one. And if you're building a piece of building a piece of software for music, it has to have good timing. Otherwise, it's not a credible musical instrument. So that's a very hard constraint. Everywhere you're making sure that the melody doesn't drift. I mean, the very first version of Sonic Pi, which I built in 2 weeks, didn't have good timing. So it was perfectly fine to teach that basic computer science lesson, and nobody noticed. But it was actually when I introduced the concurrency when it was really obvious, because you'd have two threads making a melody, one doing a melody, one doing a drum line, and they would suddenly drift out of time. Right. Like, oh my goodness. Because they were doing what sort of POSIX style sleeping, which says to ask shut the process down for some period of time.
For about this amount, please. But you don't have to if you don't want to. Kind of like it can be a bit longer if you need it to be.
Well, that's it. You say it's not about, typically it's at least plus some delta.
Yeah.
And that's like when the operating system says, okay, you're ready to crack on again. And that delta is variable every single time, and it's smaller or larger depending on the operating system. Actually, this was one of the interesting things about developing it on the original Raspberry Pi, because it's such a low-powered, low CPU-powered device. But all of these problems really became large straight away.
Right.
So those deltas that the scheduler took to wake up were large and variable, and they were really very noticeable very quickly. So this then, okay, how do I fix this? And that was interesting as well, because it was about I quite liked the semantics of the language. It was very simple, as you describe it. The focus of it was to be able to make it so that anybody can play and work with this thing. So I was like, how do I make this language keep the same from an API perspective, the language descriptions perspective, but have better timing? And so that's a lot, sort of replacing all the underlying guts. And it took me a year, actually, of walking in fields to figure it out. And of course, when the solution popped into my head, it was very simple.
It's true about these people who live in Cambridge, and they just walk through the fields thinking about stuff all the time.
And most of my day actually was going into the computer labs, meeting interesting people, talking to them in the morning, having a coffee, and then do my emails. Then having lunch, and then from lunch till about 3 or 4, I would do a solid piece of work. And I think actually that's all I need to do in a day is 3 or 4 hours of actual coding. That's all I can do really, I think. And then it depended. So I would set myself a goal every day and look at the weather as well. And if the weather was good, I'd set myself a slightly easier goal. And then if I could meet that goal, I would allow myself to shut the laptop and go out for a walk. And I'd walk for anywhere between half an hour to 2 hours, depending on what time of day it was and what the weather was like. And there were some really nice fields next to the computer labs at Cambridge that I could stroll around. And that's where I did most of my thinking. And like the design process for a feature for Sonic Pi was done there, where I was like, have all these ideas I could implement. And I'd pull one down from the ether and look at it and go, can I implement this? No. And then maybe I can implement it. Well, does the implementation tessellate well, fit well with all the other features? No, it doesn't. And then it would be, well, yes, I can implement it. Yes, it does tessellate well. Could I imagine teaching this to a 10-year-old child? So that was every time for all the ideas, it had to go through this process. And so it took a long time for any feature really to make it into the software, because I had really very stringent tests based on this philosophy that things had to be simple enough for school children, which then I extrapolated to every feature in Sonic Pi, whether it's the concurrency, whether it's the time state model, whether it's the event system, whether it's the I/O model, it's the live coding aspect. There's a lot of cool technology.
Yeah.
Every aspect of that I can teach and have taught to a 10-year-old child. And that's only because I've thought about it so deeply.
So hard, yeah. I mean, it is amazing. You were showing some of the diagrams of where, like, in terms of the components of the software as is, and I think maybe for the future as well. I can't remember. And really, you are having to tackle pretty much all the big problems, right? I mean, you're talking about things like concurrency and timing, but you're also talking about I/O. You're integrating with lots of different standards, so things like MIDI and all these different pieces of kit you need to talk to. I mean, this is kind of what I mean. It's remarkable that it is so simple, because actually you've solved a lot of really gnarly problems under the hood, you know.
When people talk about the idea of a swan, where it's looking very graceful above the water, but it's kind of like that underneath, and Sonic Pi is kind of like that. Yeah, and it's kind of like there's lots of different processes implemented in different languages. The GUI is in C++, the language runtime currently is in Ruby, the I/O is all Erlang, both Elixir and the Erlang language itself, and the synthesizers are still designed in Clojure. Yeah. Although the JVM isn't part of the runtime, it is used to compile synthesizers. And then the audio synthesis, as I alluded to earlier, is something called SuperCollider. And so having to orchestrate those and get them all fired up is kind of like having to build my own small Kubernetes to make sure all the processes are running in the correct order of the execution of the processes, make sure they can all talk to each other, make sure all the logging happens, so when things don't work out, people can send me the logs, or why on that particular platform this particular process hasn't started. Like a lot of these things are critical to implement correctly.
Plus, you implemented Kafka apparently as well.
Well, so there is a. Turns out that actually Sonic Pi is now the core of it. It's one of those things when you design something you don't want it is this time event state model, which is can be seen from multiple ways. I actually took a bunch of different actual features in Sonic Pi that I needed, like. I wanted to be able to press a button and run a function. I wanted to be able to share messages across threads deterministically. Yes. And I wanted to share time, so I wanted like thread barrier synchronization. So don't do this until this has happened across threads, but also pass the time that things happen, so this can continue at the same time as this. So it's like it has a bit more constraints than thread barrier synchronization. And so I built lots of different systems for doing this, but it turned out I could actually combine them all with this time state model, as I call it, which is kind of like a tuple space, where you can, which is like a map, like in Python or whatever, where you say, get me value foo from the map. But also you'd say at time t. Right. So, which then means that the foo is not just a single value, it's a time series. And then you can pattern match over this thing. And then you could say things like, wait for a new value in this system to come in. So events are coming into the system.
So there's almost like a stream processing component of it, or complex event processing component.
Which is the Kafka analogy, right? And Kafka does also deal with time. The time gets inserted when it gets into the system and stays there for the entire.
But it also doesn't coordinate across streams, right? Well, it didn't, and maybe it does. That was always the thing, right? I mean, with most of these pieces of kit, because that's the hard part.
Right.
But it turns out
it's necessary, absolutely. And so I've implemented that. It was a terrible implementation in Ruby, and it works-ish. And so that's now the next thing I'm going to work on. I'm going to rebuild that in Elixir.
Just sort of occurred to me that something else I sort of was thinking about was testing. And this kind of, how do you know if it works-ish or not?
It sounds right. When you run the code, you know what it's going to sound like, and you can hear that. In the same way, like the really old days, they used to listen in on the big, massive mainframe computers because they were going so slowly, they were quite mechanical. You could actually hear when they were executing correctly or not.
Well, you used to be able to do that. You mentioned about your first computer. My first computer was an Acorn Electron with the additional tape deck on the side. And you used to be able to hear, you'd know whether your game had loaded correctly because you'd turn the volume up on the tape, right? So you'd be able to hear the yeah, exactly. And then, oh no, it's Chucky Eggs not loaded again. Damn it, that kind of thing. It's
super annoying.
Yeah, really, really. I mean, obviously it's open source software. We talked a little bit. Well, I mentioned that. How does this work now in terms of ongoing funding? Obviously, you're still involved with schools and teaching and things, and you're still involved in active development of the.
That's a hard question to ask. I mean, I was initially funded, and I had a postdoc role at the university, but funding at university is hard, right? And so these things don't always work out. So that became more and more difficult to sustain and maintain, and it felt like also there was more constraints on me about having to demonstrate impact and do reporting. And I'm not really a person that's very good at those things. I'm a programmer, and I wanted to focus on my energies on that. So I had a choice really to be either to go back to being a professional programmer, or to find a way to carry on working on this, but maintaining my independence. And I had that independence in the early days because there was sufficient lack of monitoring and management of me that allowed me to do the walking in the hills and imagine all these features and build them, and no one really sort of said no. And that allowed me to develop the software as it is. And so I wanted to carry that on.
Sure.
And so that currently the funding model is really about trying to diversify the income streams as much as possible. So I no longer want to be in a position where a single organization is controlling all of the funding, because that's a sort of a power position that I don't want to be under. Because if they wanted to pull it, that puts me in a really
back to
situation.
building bankings.
And I'd rather not do that. So, so what I'm trying to do is diversify as much as possible. So currently, maybe people have more ideas about how I can change this, but currently I have half my income comes from Patreon, which is a website that lets people do small donations equivalent to a cup of coffee every month. And because that's a recurring thing, that's really sustainable. And it really gives me that sort of safety net that's really critical. That was essential actually during COVID.
Yes, right, of course,
and allowed me to survive through that terrible time. And then topping up on that, so that's about half. And when I say income, I'm talking about the income of an average researcher.
Yes.
Not an average programmer or senior programmer. So I'm not attempting for that. It'd be nice, but not. And then the other half is coming from organizations, conferences, companies hiring me to deliver party performances. So I'm live coding the music, projecting it on the screen, making people dance. I can get Finnish programmers to dance. That's my claim to fame. So that's which is a cool statement to make. And then also workshops. So I can deliver a workshop where I can go in and teach people the basics of live coding music, and because of the nature of it being for schools, that workshop works perfectly well for professional programmers who are hardened, who say, no, I don't need to learn anything new, and they'll still learn something new.
Yes.
As well as the non-programmers. And actually, if you've got an organization with programmers and non-programmers, and you want them to actually coordinate and collaborate together, Sonic Pi is a great way of making that possible. And then also talks and keynotes. I can go and deliver an exciting talk about how it works and the kind of things I'm talking about now. So those things, the money from those kind of events, they also go directly towards continued development and maintenance. And it's sort of working out, but it's very stressful.
Yes, I bet it is, and long may it continue. Not being stressful, but long may it continue being in development as an open source project. I think there's one final question I had, because I know we talked a lot about things like computer science and kids learning programming and how aspirational that could be if we could make it that way. So do you have any advice for the people who may be watching about how to maybe get involved or help, or what we could do, actually, all of us, to make this more interesting for kids?
Yeah, I mean, my advice generally is if it sounds interesting, to have a go. Play with it and share it and use it to show your children or show your friends. Because it's really hard going to parties and people asking you, what do you do? And you say you're a programmer, and they're like, not interested. So that's because we don't really have the things to talk about. You can't really talk about, I'm working on this cool Java business system with distributed whatever and Kubernetes and whatever, serverless, blah, 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 blah. No one really knows what any of those words mean.
Including us, I think, half the time. But,
Definitely got servers. Like, where are the servers? So that's whereas with something like Sonic Pi, actually, it gives you an opportunity to talk to non-programmers in a party situation about programming in an interesting way and get them engaged. So definitely give it a go, have a play. I think actually probably the most important thing people can do is to find their local school and offer their help. Find the computer science teacher and say, I'm willing, as a professional programmer, to come into your school and run a code club or give a talk or show something about the work I do, trying to make it real and understandable to the children. I think schools are crying out for professional programmers to get involved with them. So that would be what I would do. And of course, then use Sonic Pi is one of the things going to show. And then if you really like what I'm doing and you're supporting the approach I'm taking, then support financially. So if you're an individual, Patreon is a great way of doing it, just $1 a month. Enough of those add up, and I really don't need to stress about the money. Or if you're an organisation that wants a party or wants a workshop, then hire me, and I'll be really happy to join them.
Perfect. Okay. Well, thank you very much, Sam. Thanks for joining us on GOTO Unscripted. It's been an absolutely brilliant interview. Thanks again.
And thank you for your thoughtful questions.
I would be blushing, but behind the beard, you can't tell. So that's why I grow up. Yeah, thanks very much, Sam.
Thank you very much.
See you another time. Bye-bye.
Cheerio.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.